in the topping cycle type of CHP, or combined heat and power system, we first produce that mechanical energy. So the mechanical energy comes from a turbine, typically a steam turbine. Remember that mechanical energy is often a rotating shaft that does work. And of course, you could hook up that rotating shaft to a generator in order to make electrical energy as well. And then secondary to that is the residual thermal energy. So first, we are creating that work energy, and that work energy could be used for electricity. So first, we're doing that, and secondary, we're using this thermal energy. So that's what a topping cycle does. So we're going to draw a diagram here where the steam generating unit is going to burn its fuel to produce some steam. The steam is going to turn a turbine that makes your shaft power or your work, which you could turn into electricity by connecting it to a generator. And then we are going to bleed that steam out at an intermediate pressure in order for it to go to provide thermal energy to, let's say, a process or space heating, etc. So I would say that it all sort of centers around a steam turbine. So this steam turbine, again, this is giving us that useful work that we want, right? The useful work here is coming out of this shaft, which of course we could attach to a generator. And this is our steam turbine. And that's our work output, which is our first, primary purpose for having this system. How do we run that steam turbine? Of course, we're going to run that with steam. So that steam is going to come from a boiler, or we can just say here generically a steam generator. Typically in a conventional system, we would be burning a fuel. So this is still not a low carbon type of technology, but this is a more efficient technology than if you were not capturing the heat energy afterwards. And then the second thing we're going to do is we are going to take some of this intermediate pressure steam, because remember, we go from high P to low P over here. And we're going to take some of that intermediate pressure steam, and we are going to put that into a heat exchanger. And for whatever we need it to be doing, so maybe some process heating. Space heating, etc. So I'll just make that look like a heat exchanger here. Beyond that, we really just have to sort of connect the system. Of course, we still have some more steam in this turbine that is low pressure steam. Why not use that steam? So we would put that into a condenser. Once it is condensed, it would be water, right? So then we can recycle that back to a feed water tank. And then this intermediate steam also went through some processing, and it would have lost its energy. It would have turned into a liquid state, right? This is a liquid state. And that liquid state can go into that same feed water tank, yes, and pump into the turbine. Back into that boiler. So it looks like a closed loop, a continuous loop. Something doesn't make sense here though, right? Because you can't really generate that much steam and then use that steam and convert that steam into work. And then we've converted that into, so this is our work here, right? Which is good. That's what we wanted to do this for. And of course, this is our second form of energy here, which is our heat energy, which is also, we are happy about. And this is where we spent the money into the fuel that goes in here. But doesn't really make sense because we can't take this much steam and create work and create heat energy without some losses in the system. So we would just be topping this up. We would be topping this up with some just some makeup water. And that's how a topping cycle type of CHP system would be configured.